A research hospital tries a new antibiotic scrub before surgery to see whether it can lower the rate of infections of surgical sites. And the old infection rate is 5%. So the null hypothesis is that the proportion of infections is 0.05. And here the p-value is also 0.05. So it looks like they get a sample of 700 surgeries with the new scrub, and then there's 28 infections. We want to find the test statistic z for this. So just to get an idea of if this new scrub is better, we can find the proportion of infections. So I'm going to use a calculator to do that. So that was 28 infections out of 700 surgeries, which is a 4% infection rate, which is lower than the old rate of 5%. But is it, significantly better? And that's what the test statistic can tell us. So I'm going to solve this problem in StatCrunch. There are formulas for finding z, but StatCrunch can do this too. So I'll go to question help and choose StatCrunch. Try that again. All right, so what I'm going to do is go to where it says stat and go down to proportion stats since we're talking about proportions. There is one sample that we're working with, and the information is summarized from this sample. So opens this thing up for us. The number of successes is 28 out of 700 sample size. And we're doing a hypothesis test where p is equal to 0.05. So I have to change that to 0.05. Now, the alternate hypothesis is, we think that this new scrub actually will lower it. So we're going to say that the new proportion is less than 5%. Okay, so I'm going to click compute, see what we get. All right, so here is the information from the hypothesis test. So this was the information I entered with that 4% sample proportion. It gives us the standard error, but it also gives us this z-stat, which is the test statistic. It says to round it to 2 decimal places, which is negative 1.21. So I'll enter that here, negative 1.21. I'm going to check my answer. Okay, that's correct. And now we're asked to explain this in context. Okay, so the value of the test statistic tells that the observed proportion of infections was, I think I'm going to leave it as positive. I'll put 1.21, so I'll just ignore the negative for now. So it's 1.21 standard errors below the hypothesis proportion. So the reason I didn't include the negative is because the below indicates that we're going to be to the left as opposed to the right. So basically, it's over a standard deviation away. So I'm going to check my answer. And that's it for this problem.